test. So the directions say to solve this one first and use this to solve that. But what I'm going to do is I'm going to show you, because this one seems scary, and I'm going to show you that this one is exactly the same as that one, just more abstract. So if you weren't looking at that scary thing and you were just asked to solve this equation, you would go la-di-da-di-da, I can totally do that. I'm going to subtract 3x from both sides. And you would do 8x minus 3x, and you would call that 5x in a heartbeat, right? Da-da-da-da. Excellent. And then on this side, you have the minus 10. When we go to do it on this side, we're going to do the same exact thing. You're going to subtract bx from both sides to get all the x's over onto this left side of the equation. But when you go to subtract, you're like ax minus bx. That's weird, right? I don't just know that's, I can't, it's hard for me to see that subtraction. But it is just ax minus bx, just like this one was 8x minus 3x. And on this right side, we happen to be able to say it was 8 minus 3 x's, so it was 5 x's. We were able to actually do that subtraction. On this side here, we're going to say it's a minus b x's. Basically, you have a x's minus b x's, so you have a minus b x's. It's a reverse distributive property. If you were to distribute with your little rainbow rule and distribute that x back in, you would end up right back there. So we've got that going on. And so we have a minus bx, and I still like to keep this separated, equals bx minus c. Oh no, the bx's went away, sorry. Equals a negative c. And then we're going to solve for x. So on this side, it would have been, bring down that negative 10 equals negative 10, and we'll divide both sides by 5. So we get x equals, this we were able to actually do that division, but on this side, when we go to divide both sides by a minus b, that'll go away, and we'll just have to leave the right side as negative c over a minus b. Okay, I think I'm going to do that one more time because a little bit more smoothly. So let's do it without so many interruptions. So we'll do the right side, and we'll have that mirror the left side. So we're going to subtract 3x from both sides. So here we're going to subtract bx from both sides. So what that gives us is a minus b x's. And then this one was 8 minus 3 x's, which we happen to know was 5, but we'll leave it there. And then that just equals what's left. And then the last step to get rid of that, we just divide by the 8 minus 3. So we just divide by that. And then this is just negative c over a minus b. And this is negative 10 over 8 minus 3, which we know is negative 10 over 5, which we happen to be able to do as 2. So, yeah. And we'll do, as you do more, you'll kind of get more of the feel for it. We'll get more into a rhythm. So if this one looks scary, that's okay. It's the first time. They wanted you to show that you could substitute in, like a is 8, b is 3, and c equals negative 10, comparing this guy to that guy, and put that in so that you do get what we got there, so that you do get the -2. So it's neat to be able to solve things in abstract. You're going to come across a lot of formulas in physics and in chemistry where you'll have a set formula, and instead of and you'll want to maybe solve for x, and instead of starting with this formula every time, you'll want to start with the one solved for x. And so being able to manipulate it, it's useful, believe me. So we're going to pause this and we'll do the second one, and okay, so we do it again. If we were looking at this equation, which is less, just on that side, sorry about that. So if we were looking at this side, this is less scary. And if we were solving this, we would undo this division with multiplication. We would multiply both sides by 7 to cancel out that division, and we would just end up getting 14 equals x plus 5. So if we do the same thing over on the left side, if I multiply both sides by b, that'll go away. And then the left side is just whatever b times c is equals x plus a. Cool. And so it's almost nicer, right? I don't have to know any multiplication. I'm just like, whatever b plus times c is. So we go back over to the right and we're solving for x. So I got to get rid of the 5 by subtracting 5. And I happen to know what 14 minus 5 is, but I'll just leave it there for now. Well, no, I'll just say 9. And we've solved the right side like normal. If we do the same thing on the left, just like I subtracted the 5 over here, I'm going to subtract the a over there. And the best I can do with the left side is say it's BC minus A. And then you just get to leave it there. Yeah. There you go. Okay. All right, so again, we're going to start with the less scary side. If you were solving the right side and trying to get that x alone, you would subtract 6 from both sides to get rid of that. And you would be left with x over 4 equals, and we happen to be able to do this, that's just 7. If we do the same thing on the left, just like you subtracted the 6 over there, we're going to subtract the b over here, and so that those will go away. And then I have x over a equals c minus b. And I don't know what that is, but I just get to leave it. Back over on the right, to solve this, you would multiply both sides by 4 to undo that division, and it would leave you with x equals 7 times 4, we happen to know is 28. On the right, just like you multiplied by 4 on this side, you're going to multiply by a on both sides to get rid of that, and you'll just have x equals c minus b times a, whatever that is. And there you go. If you were matching this up, they wanted you to solve this scary side first and use your answer to solve the other side. So if you match this up, it looks like our A is 4, our B is 6, and our C is 13. So if I take my answer here and I replace, it'd be x equals my C, we said was 13, and then minus my B, we said was 6, and my A was 4, just kind of matching that up. Let's see if it gets the 28 that it should be. This is 7 times 4 is 28, and everything is right with the world. Excellent.